All right, so number 20 has this weird strut thing. I don't know where this word strut comes from. And I'll not make a terrible Bob Seger joke, because I don't like Bob Seger. Sorry, mumbling to myself. All right, so you've got this weird board thing that they call a strut, and there's a, a weight hanging over here, and you've got this tension that comes over to here and holds the thing in place. And you're actually given a mass of the strut itself, which is going to act here, yes? All right, so a couple things. When you're solving for torque, this is just a general comment, problem-solving strategy. When you're solving for torque, we've learned now 3 different ways of doing it that all amount to the same thing. That's one option, right? Find your lever arm, then find the component of the force that's perpendicular to that lever arm and multiply, right? So when would you do this? I would do this in a scenario where you've got a lever arm that's simple, but a force at a weird angle. Good? All right. We've also learned that sometimes it's easier, instead of splitting up the force, to split up the lever arm. So I would do that in a situation where your lever arm is at a weird angle and your force is nice and simple, right? Because then you find the perpendicular component of your lever arm. Cool? Now, if neither of those two things seem simple or intuitive, like to me that last problem was a perfect example where doing this made some sense, right? Because all of your forces in this problem were either horizontal or vertical, but it was the beam that was at a weird angle, right? So I just found the horizontal and vertical components of the beam and used that. Follow? Yeah. All right. But in this problem with this stupid strut, there's all kinds of weirdness going on. The strut is at a weird angle. This tension force is at a weird angle. So when that happens, my strong recommendation is to just go to this. So here, F is the actual magnitude of the force. D is the actual length of the lever arm. How far is it from your chosen pivot point to where the force is being applied? Okay? And what does theta represent? The angle between those two vectors. Follow? All right. So with that in mind, let's do this. So let's think about what forces are acting on this strut thing. I'm going to calibrate my board, or I'm going to punch somebody if I don't. So don't want to do that.
Oh my gosh.
Come on, Peter. Okay, so let's identify the forces that are acting on the strut. So I'm going to kind of clean this up a little bit, and let's make a new drawing. So here's the strut. Okay, so forces that act on it. There's a tension force pulling it this way. There's the force of gravity from the 225 kilogram thing, right? So let's call that force of weight, which is 225G. Good? There's the force of gravity on the strut itself, and it tells you that it's uniform. So the force of gravity, it's 45 times 9.8, right? So 45G. Good? And then there's the hinge over here doing something. I don't know what. So that hinge is going to have 2 components to it, right? So vertically, which way does the hinge have to be pushing? Up, right? In fact, remember I said before, I always start by looking at the forces. Right away, I can figure out the vertical force from the hinge, right? The force of the hinge vertically has got to be big enough to cancel these 2 downward forces, right?
Wait, isn't the tension?
Oh, thank you. Thank you. You guys, yes. Yeah, the tension's pulling down too. So you're right, I don't know that. Thank you. It's funny, I just said that to somebody during tutorial, and then I started to make that same mistake. Okay. So yeah, so the hinge has to push up with enough to cancel all three downward forces. All right, and then horizontally, what's going on? Right or left? Right. It's got to be pushing right. So the force of the hinge in the x direction. Okay, so let's go through that. I think we've already sort of resolved it, but So if we write an equation for our net force horizontally, what that tells me is that the force of the hinge horizontally plus the force of the tension horizontally has got to be 0, right? But that doesn't help me because I don't know either of those dudes, right? Cool? All right, similarly, vertically, as you guys were quick to point out, there are 3 vertical forces. There's gravity, the force of the weight, the force of tension vertically, and then the force of the hinge vertically. So those all have to add up to 0, right? Again, nothing there really helps me because there's 2 unknown forces in that equation. So we got to go to net torque. Good? All right, so net torque. What should we choose as our pivot point? Yeah, I think the hinge again, right? Because then we only have 1 unknown force, right? Yep. Okay, so mark it with a P. So my net torque around point P should be, well, it should be the torque from the gravity on the beam, plus the torque from the weight at the end, plus the torque from tension. And it all has to add up to 0, right? Good? All right, so let's see. We're not given a length of the strut, right? So did most of you just call it D, I'm guessing? Is everybody okay with that, just calling that D? So this distance here, I'm going to call D. Doing so tells me this distance should be half of that, right? D over 2. Follow or no? Doesn't it tell you the strut is uniform? A uniform strut of mass blah, 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 blah. Okay, so here we go. So our net torque is 0. The torque from gravity. So I don't know. I mean, I guess you could do some trig and find this horizontal distance. But I know I'm going to have to do some trig to deal with this tension thing. So I'm just going to do FD sine theta for all of them. Everybody okay with that? All right, so if I do that, let's see. For gravity, my force is 45G. My lever arm is D over 2 times the sine of, what's this angle here, you guys? I think it's 45 degrees, isn't it? Doesn't it tell us the strut? Is it a 45-degree angle?
It should be 45.
So it's a 45, 45, 90 triangle. Follow? So just to keep score, so torque of gravity, plus the torque from the weight, well, that's going to be very similar. It's going to be 225G times, what's the lever arm for my weight? All of D, again, times the sine of 45. So torque from the weight, plus the torque from tension, which is force of tension times D times the sine of something. So what's that something? I did not give myself enough room to draw this, so I'm going to make a kind of smaller drawing down here. So here's the strut, here's the tension. So we know this angle here we know is 45 degrees, and the problem told us that this angle was 30 degrees, right? Everybody good up to there? We need this top angle up here, don't we? Anybody see how to find it? You got to do 2 steps. What do you got, Adam?
Just do 180 minus 45.
Yeah, 180 minus 45 gives us this guy, right? So that's what, 135? So then,
Plus 30 and then the angle.
yeah. So this little red triangle here has got to add up to 180, right? So 135 plus 30 is 165. That means this has got to be 15 degrees. Cool? All right. So any problems up to there? All right. So solving this, so, you know, I guess you can go ahead and cancel out the D's, right? And, you know, solve it. Do I need to go through the algebra on this? Okay, so that tension force turns out to be whatever the answer was on the sheet. 6,600 and who? 30? Cool. So there's your tension force. Are we good with that? Cool. All right, so now what we need to do is, well, what was the original question? I guess I sort of jumped the gun here. Let's see. That was A, was find the tension. Okay, cool. Part B wants the horizontal component of the force on the strut from the hinge. So you just use your trig, right? You've got, let me just do this. So we just found our tension force to be 6630. We know that that was at an angle of 30 degrees to the horizontal, right? Not 15, so be careful there. So we can find our components. So here's our force of tension in the x direction, force of tension in the y direction. So the y direction is going to give you what, 3315? And this, I don't know, we got to figure it out. Oh, well, it's on the answer sheet. 5740. Everybody cool up to there? Questions, you guys?
Where is this 30 coming from?
It was in the original problem. It showed you, oh, why does it keep doing this? It told us that this angle down here was 30 degrees. So alternate interior angles. Good? Everybody good? Okay, so at this point, now we know those components and we can go back and plug stuff into here and find your, what are we trying to find, the last part? The vertical component of the force. So at this point, we've got everything except the vertical component from the strut, right? So I think we can finish it, right? So, all right, so let's see, our net force vertically has got to be 0. Our FG is negative 45G. The force of the weight is negative 225G. The force of tension in the y direction was, what did we decide it was, 3315? Plus the force of the hinge in the y direction, and solve for it. And hopefully that gives you the answer that was on the sheet. Yeah. Problems, you guys? All right, so again, you guys, most of these problems are kind of solved using the same process. You list these three equations. There's net force in the x direction, net force in the y direction, net torque equals 0. And just sort of figuring out which one helps you the most, you know? All right, so that's that.